Welcome to our channel. Today we will take you on a fascinating journey through space to discover planets that may support life. We will explore places like Europa, Jupiter's moon, where oceans might lie beneath the ice, and exoplanets like TRAPPIST-1e and K2-18b, where signs of water have been found. You will also learn how the stability of planets like Kepler 452b could support life for billions of years. Stay with us to find out if we are alone in the universe. Imagine a world where massive oceans lie beneath an icy surface. This is not science fiction. Europa, one of Jupiter's moons, might be such a place. Scientists are fascinated by the possibility of life existing there. But that's not all. On Enceladus, Saturn's moon, geysers have been discovered ejecting water into space. Does this mean that an ocean also exists beneath its icy crust? Next, we have Mars, which, although currently dry and cold, shows evidence of ancient rivers and lakes. Finding water on Mars is key to understanding if life could have ever existed there. But that's not the end. The planet Kepler 22b, located 600 light-years away, is 2.4 times larger than Earth and is in the habitable zone of its star, similar to our Sun. This planet has garnered particular interest because its orbit is at a distance from the star that could allow liquid water to exist. The average temperature on Kepler 22b is around 22 degrees Celsius, making it even more Earth-like. Additionally, Kepler 22b has a year lasting 290 days, which is close to our Earth year. Scientists believe that this planet may have a thick atmosphere that could protect potential life forms from cosmic radiation. Do its oceans hide life? Could there be forms of life completely different from those we know on Earth? These are fascinating questions that scientists around the world are asking. Let's move to exoplanets, planets outside our solar system. There, each atmosphere may hold secrets. TRAPPIST-1e, one of the 7 planets orbiting the cool star TRAPPIST-1, is located 40 light-years away from us. Its mass is 0.62 times that of Earth, and its diameter is similar to our planet. Interestingly, TRAPPIST-1e lies in the so-called habitable zone of its star, which means that liquid water could exist there. The star TRAPPIST-1 is much cooler and smaller than the Sun, so the planets have to orbit very close to it to receive a suitable amount of heat. TRAPPIST-1e orbits its star every 6 Earth days. Does this mean that a year on this planet lasts only 6 days? Yes. It's incredible how diverse the conditions can be on other worlds. Another example is K2-18b, located 124 light-years away, 8 times larger than Earth. Scientists have discovered water in its atmosphere. This is the first such case on an exoplanet in the habitable zone. K2-18b orbits a red dwarf, which means its star is smaller and cooler than our Sun. The planet has a dense atmosphere that can protect against cosmic radiation and maintain suitable conditions for life. Moreover, the presence of water in the atmosphere suggests the possibility of clouds and rainfall, a crucial element for sustaining life. Can you imagine rain falling on the surface of a planet 8 times larger than Earth? Additionally, the planet LHS 1140b, located 40 light-years from Earth, is a super-Earth orbiting a cool red dwarf. This planet is about 6.6 times more massive than Earth and has a radius 1.4 times larger. Its dense atmosphere and potential oceans may support life. LHS 1140b is in the so-called habitable zone, which means it is at a distance from its star where liquid water can exist. The planet also has a strong magnetic field that can protect against harmful radiation. Interestingly, due to its size, LHS 1140b can maintain an atmosphere for a long time, increasing its potential to support life. Energy from stars. Stars provide the energy that can sustain life on distant planets. Proxima Centauri b, the closest exoplanet to us, orbits the nearest star outside our Sun, located just 4.24 light-years away. Although it is in the habitable zone, it is exposed to intense radiation. Proxima Centauri, a red dwarf star, often emits strong flares that can affect the planet's atmosphere. However, some scientists believe that if Proxima Centauri b has a strong magnetic field, it could protect the atmosphere and potential life from this radiation. The planet is only 1.17 times larger than Earth, making it an extremely interesting place for research. Imagine a journey to this closest exoplanet. It could be the first target of future interstellar missions. Other interesting planets include Ross 128b, orbiting a quieter red dwarf star, located 11 light-years away. It is 1.35 times larger than Earth and may have more stable conditions. Ross 128, unlike Proxima Centauri, is much quieter, meaning fewer flares and less risk to the planet's atmosphere. Ross 128b also has a surface temperature that could be similar to Earth's, making it an even more likely place to search for life. This planet orbits its star every 9.9 days, which is a very short year, but its star is cool enough that it could create conditions suitable for life. The planet Kepler 186f, the first discovered Earth-sized exoplanet in the habitable zone, is located 500 light-years away from us. Its orbit allows it to receive a similar amount of energy from its star as Earth does from the Sun. Kepler 186f is only 10% larger than Earth and orbits the red dwarf Kepler 186. The planet receives about 1/3 of the light that Earth receives from the Sun, giving its atmosphere a chance to maintain liquid water. Kepler 186f is located in the constellation Cygnus and is one of the most exciting planets discovered by the Kepler telescope. Chemical elements in space: carbon, hydrogen, nitrogen, oxygen. These elements are the building blocks of life. But do they exist on other planets? Let's start with Titan, the largest moon of Saturn. The hydrocarbons discovered on its surface are a true treasure trove of chemical wonders. On Titan, there are lakes and seas composed of liquid methane and ethane, as well as organic molecules that could be the building blocks of primitive forms of life. Imagine a world where rain is made of methane, and rivers and lakes are not water, but liquid hydrocarbons. It's a completely different exotic chemistry that could hold the secrets of life. And what about the planet Gliese 500e, located 20 light-years away? It is in the habitable zone of its star and is about 3 to 4 times larger than Earth. The discovery of this planet sparked great interest among scientists. Gliese 500e orbits a red dwarf star, which is much cooler than our Sun. But because the planet is at the right distance, liquid water could exist on it. Its mass suggests that it could have a dense atmosphere capable of supporting life. Could there be oceans on this distant planet where life is hidden? Another fascinating planet is HD 85512b, located 36 light-years away. It is 3.6 times larger than Earth and is on the edge of its star's habitable zone. This means it could have the right conditions for liquid water to exist. HD 8552b orbits an orange dwarf star, providing it with stable lighting conditions. This planet could have climates similar to those on Earth, with clouds and rainfall. Imagine mornings on HD 855112b, where the sunrise looks different than on Earth. But we could still see a sky full of clouds and rain falling on its surface. Planetary stability. Stable conditions for millions of years. This is key to the evolution of life. Imagine the planet Kepler 452b, located 1,400 light-years away, an older and larger version of Earth. This planet, sometimes called the older cousin of Earth, may have had stable conditions for billions of years. Kepler 452b is 60% larger than Earth and orbits a star similar to our Sun, but its star is about 1.5 billion years older. This means the planet has had more time for life to develop, if it exists. On Kepler 452b, a year lasts 385 days, which is close to an Earth year. Scientists speculate that if the planet has a thick atmosphere and water, it could possess lush forests, vast oceans, and diverse forms of life. Imagine landscapes similar to Earth, but on a much larger scale, with unknown plants and animals. And what about the planet LHS 1140b? This super-Earth, which may have a dense atmosphere and liquid oceans, is located 40 light-years away from us. LHS 1140b is about 6.6 times more massive than Earth and has a radius 1.4 times larger. It orbits a cool red dwarf star, which means it is in the habitable zone where liquid water can exist. Due to its size, LHS 1140b can maintain an atmosphere for a long time, increasing its potential to support life. Imagine a planet with vast oceans and an atmosphere rich in gases that support life, where day and night could last much longer than on Earth. The stability of these planets makes them some of the most promising candidates for habitation outside our solar system. Long-term, stable conditions are crucial for the development of complex forms of life. For example, Earth has had stable conditions for billions of years, allowing for the development and evolution of diverse organisms. Planets like Kepler 452b and LHS 1140b could offer similar, if not better, environments for life. Exploring life on other planets is one of humanity's greatest challenges. For life to exist, a planet must meet specific conditions: the presence of liquid water, a suitable atmosphere, a stable climate, and the right chemical building blocks. Thanks to our research on these elements, water, atmospheric composition, solar energy, essential chemical elements, and stable conditions, we are getting closer to groundbreaking discoveries. Each new planet offers hope and raises new questions. Are we alone in the universe? This question remains unanswered, but our mission to find out continues. Thank you for watching, and don't forget to subscribe to our channel so you won't miss our next exciting episodes. See you soon.